Okay, in section 1.2, we're going to look at intercepts and symmetry are the two big topics. Problem 1, we're going to find the intercepts. So problem 1, we set our x-intercepts and y-intercepts equal to 0. When I find the x-intercepts, I let the y be 0, and I solve for x. When I find the y-intercepts, I let x be 0, and I solve for y. When x is 0, I just have y equal -3. When y is 0, I got 2x squared minus 5x minus 3 equals 0. Or that's going to factor as 2x plus 1 times x minus 3. So 2x plus 1 equals 0, or x minus 3 is equal to 0. So I get 2x plus 1 equals 0, or x minus 3 equals 0. X is equal to -1/2, or x is equal to 3 would be the two solutions. So the intercepts that I would get are -1/2 0, and 3 0, and 0 -3. Okay, now in the next example, I've got y equals x to the 4th minus 2x squared minus 8 equals 0. That's like a quadratic equation, although instead of ax squared plus bx plus c equals 0, I got just the powers of x are different. They're 4 and 2. The same idea would apply though. Okay, to find the y-intercepts, I'm going to let x be 0 and solve for y. To find the y-intercepts, I'm going to let, to find the x-intercepts, I'm going to let y be 0. To find the y-intercepts, I'm going to let x be 0 and solve for y. When I let x be 0 and solve for y, I get y equal -8. And when I set y equal to 0, I get x to the 4th minus 2x squared minus 8 equals 0. So u is equal to x squared, means that u squared minus 2u minus 8 equals 0. Okay, if u is equal to x squared, and I square both sides, u squared would be x to the 4th. U would be x squared. Okay, so I get x squared minus 2u minus 8 equals 0. That means that u minus 4 times u plus 2 equals 0. Or u is equal to 4, or u is equal to -2. Now, I don't care what u is. U is x squared, and I'm solving for x. So let me substitute back. U is x squared. I got x squared equal 4, or x squared equal -2. X squared is equal to -2 is going to have no real solutions to it. When I square a negative, I get a positive, right? So I'll never have a true statement on that one. X squared equal 4 means that x equals plus or minus 2. So the intercepts would be 2, 0, -2, 0, and 0, -8. Okay. The next one I've got 4x squared plus 9y squared equals 36. And so same idea. I need to let x or y be 0 to find the x-intercepts, and to find the y-intercepts, I need to let x be 0. So when I let y be 0, I've got 4x squared equal 36. X squared is equal to 9, so x is equal to plus or minus 3. And when I let x be 0, I got 4y squared equals 36. So y squared would be equal to 4, or y would be equal to plus or minus 2. Okay, I'm going to have 4 intercepts here, looks like. They're at 3, 0, -3, 0, and then 0, 2, and 0, -2 for the y-intercepts. Okay. The next one is y is equal to x squared minus 5 over 3x. So to find the x-intercepts, I need to let y be 0 and solve for x. To find the y-intercepts, I need to let x be 0 and solve for y. When I let x be 0, I'm dividing by 0, negative 5 over 0. So there's going to be none of those. Okay? The x-intercepts are found by letting y be 0. So x squared minus 5 over 3x equals 0 means that x squared is equal to 5 when I multiply both sides by 3x and add 5 to both sides. X would be plus or minus root 5. Okay, so there's going to be two intercepts then on this graph. 5, 0 and negative 5, 0 are the two intercepts on this graph. Okay. Another major idea of in this section is it deals with symmetry, and so a graph is symmetric to the x-axis if it contains both xy and x negative y. Symmetric to the x-axis. Okay, so let's first find the intercepts and then plot some points. If I let x be 1 minus y squared as an example, then to find the x-intercepts I need to let y be 0. Well, I'm going to have x equal 1. And to find the y-intercepts I need to let x be 0. 1 minus y squared equals 0 means that y squared is equal to 1, or y is equal to plus or minus 1. Okay, so I'm going to have two y-intercepts, 0, 1 and 0, negative 1, and then an x-intercept at 1, 0. Let me plot this curve. So I've got three intercepts at 1, 0, 0, 1, and 0, negative 1. Okay, and I've just selected two more values. If x is 2, or if y is 2, 1 minus 4 is negative 3. So negative 3, 2 is on the graph. And if y is negative 2, I also get negative 3. So negative 3, negative 2 is on the graph. Okay, and it looks like it's I'm going to have something that's symmetric to the x-axis. And so whatever value point that I select, the opposite x value is going to produce the same y value, in other words. I end up getting a parabola that is kicked on its side facing towards the left. And this would be symmetric to the x-axis then. If I spin the graph about the x-axis, I get the same picture. Now a graph that's symmetric to the y-axis is going to be one that you can spin about the y-axis. It's going to contain both xy and negative xy. All right. So for example, suppose that y is equal to x to the 4th minus 2x squared. Well, to find the x-intercepts, I need to let y be 0. To find the y-intercepts, I need to let x be 0. The y-intercepts are 0. So there's only going to be one of those. To find the x-intercepts, I need to let y be 0 and solve for x. X squared is in common to these two terms, so I can factor that out. The x squared equals 0 and x squared equals 2. X would be plus or minus root 2 and x is 0. So 0, 0, 2, 0, and negative 2, 0 are the three intercepts on this graph. So here I've got a table of values. 0, 0, negative 2, 0, negative 2, or root 2, 0, Root 2 is roughly about 1.4, if you check that. Negative root 2 is 0, negative 1.40. Okay, so I got a table of information. 0, 0 is on the graph. If x is 1, 1 minus 2 is negative 1. And by the way, you'll notice that I'm using a table as I normally would here. Over here it was reversed because I'm solving for x. Okay, so in this case I'm solving for y, which makes this different. But if x is 1, then y is negative 1. If x is negative 1, then negative 1 to the fourth is 1. Negative 1 squared is 1. 1 minus 2 is negative 1. Negative 1 is on the graph. If x is 2, 2 to the fourth is 16. Minus 2 squared is 4. Times 2 is 8. So 16 minus 8 is 8. So here's 2, 8 on the graph, about right here. And then negative 2, 8. Is on the other side, about right here. Okay. Root 2, 0, and negative root 2, 0 are my x-intercepts. And that's something I've already said before. But basically, I have a curve that's going to be heading downward, coming up, going through the origin, going down, and going up again. And so this is me 3 turns, and so this graph is symmetric to the y-axis. If I spin the graph about the y-axis, I get the same picture. In other words, okay. So a graph is symmetric to the origin if it contains both xy and negative x, negative y on it. As an example, suppose that y is equal to x cubed minus 3x. Find the x and y intercepts. The x-intercepts we let y be 0. The y-intercepts we let x be 0. When x is 0, we get y equals 0. When y is 0, we get x cubed minus 3x equals 0. X is in common to both those terms, so I can factor that out and set that to be equal to 0. X is 0, and x squared equals 3, so x equals plus or minus root 3. So 0, 0, 3, root 3, 0, and negative root 3, 0 are the 3 intercepts on this graph. Okay, and you've got those points plotted. Root 3, 0, that's about 1.730. Okay, so here's negative 1.730. 0, 0 is on the graph. If x is 1, let's see here. If x is 1, we get 1 minus 3 is 2. So y is negative 2. Here's 1, negative 2. If x is negative 1 plus 3 is 2. Here's 2. If x is 2, 2 cubed is 8, minus 2 is 6, minus 6 is 2. So here's 2, 2 on the graph. And if x is negative 2 cubed is negative 8. Plus 6 is negative 2. Negative 2, negative 2. If x is 3 or negative 3, we get 0, which I've already got there. And so I end up getting a curve that takes 2 turns on it. And this graph would be symmetric to the origin. Okay, and basically how I see that is because any point that I plot on this graph, negative x, negative y is also going to be on the graph. Okay, so like here's 1, negative 2, negative x, negative y, negative 1, 2 is also on the graph. Here's 2, 2. Here's negative 2, negative 2 is on the graph. Okay. So we have some symmetry tests we're testing a graph to see if it's symmetric to the x-axis, the y-axis, or the origin. To see if it's symmetric to the x-axis, replace y by negative y and see if you get the same equation. To see if it's symmetric to the y-axis, you replace x by negative x and see if you get the same equation. And if you test for symmetry to the origin, you replace x by negative x and y by negative y and see if you get the same equation. Okay? So I usually make 3 columns here. You'll do the same thing. To test for symmetry to the x-axis, you replace y by negative y. And notice how when I do that, I don't get the same equation. Okay, and that's what I'm checking for. That's the only thing I'm checking for, is that I get the same equation. If I check for symmetry to the y-axis, I replace x by negative x and check if I see if I get the same equation. Negative x squared is the same as x squared. So yeah, we're going to be symmetric to the y-axis. Symmetric to the origin means that if you replace x by negative x and y by negative y, you check and see if you get the same equation. Well, if I replace x by negative x, I get the same thing, but replacing y by negative y means that I've got a negative y instead of a positive y. Okay, so the only spot where there's going to be symmetry is on the y-axis. Okay, now here's another one. X minus 1 squared plus y squared equals 4. Okay, so let's see if this is symmetric to the x-axis, the y-axis, or the origin. The x-axis, you replace y with a negative y. And when I say replace y with a negative y, I also mean, you know, replace y with a negative y, but include parentheses around that negative y. If you don't, then you want to do the same thing. So negative y, the quantity squared, is the same as y squared. X minus 1 squared plus y squared equals 4. That's exactly the same as the original equation that we've been given here. And that's you know, something to keep in mind, is that, you know, I'm trying to get the same equation as I started off with. When I replace x with a negative x, here I've got 2 of them, and when I FOIL that out, I've got x plus 1 squared. I need an x minus 1 squared. So no, that's not going to be symmetric to the y-axis. It's symmetric to the origin, means you replace x with a negative x and y with a negative y. Okay, we've already seen that there's no issues with replacing y with a negative y. Replacing x with a negative x means I've got x plus 1 squared plus y squared equals 4, and so yeah, that's an issue. I need that to be a x minus 1 squared plus y squared equals 4, and that's an x plus 1 squared plus y squared equals 4. So no. Okay, the homework is on page 23. Check out the problems that are listed there.